students, in this video, let's solve two questions based on geometric progression and then let's learn what is harmonic progression. First of all, the question given here is find the following sum 5 plus 55, 555, 5555 plus so on up to n terms. So in the first term we have 5 written only once, then in the second one we have 5 two times. So in the nth term we will be having 5 5 5 so on up to n term, nth position. So let's solve this. First of all, let's find out whether it is AP. So the difference of second and first term is 50, and if we see the difference of second and third, it is 500. So it is not an AP, as the difference here it is 50 and here it is 500. So both are not same. So it is not arithmetic progression. Now let's find out whether it is geometric progression or not. If we divide second term by first one, we get 11. And here dividing third term by second term, we get 555 upon 55, which is 111 upon 11. It is not 11. So these two are not equal. So it is not a geometric progression. Now it is not arithmetic progression and nor a geometric progression. So let's convert it into geometric progression. So first of all, what we can do is we can take 5 common. So taking 5 common, here we get 1 plus 11 plus 111 plus 1111 so on up to n terms. Now let's multiply these numbers by 9. Now since we are multiplying all these numbers by 9 and we don't want to change the meaning, so we have to divide by 9. So multiplying and dividing by 9, we get 9 plus 99 plus 999 plus 9999 so on. Now why 9? Why not other number? Because for 9, first 9, we can write this as 10 minus 1. Then 99 can be written as 100 minus 1. Next number is 1000 minus 1. So we get a pattern there. So each bracket is 10 raised to a number. Here it is 10 raised to 1, here it is 10 square, 10 cube, so on. And all the terms, all the brackets, they have minus 1 as second term. Now let's collect the first term from these brackets. So collecting the first term, we have 10 plus 100 plus 1000 so on up to n terms. Minus 1 minus 1 minus 1. Take minus sign common. So in the bracket we have 1 plus 1 plus 1. How many times? N times. Why n times? Because we have n terms and each term has that minus 1. So n times we have 1. So this is 5 by 9. Now this is 10 raised to 1. This is 10 square, 10 cube. See, first term is 10 raised to 1. Second, 10 square. Third, 10 cube. So nth one is 10 raised to n. Minus 1 plus 1 plus 1 n times. 1 plus 1 plus 1 3 times is 3. 1 plus 1 plus 1 10 times is 10. So for n times it is 1 into n. Now this bracket 10, 10 square, 10 cube, we can see that it is geometric progression. As multiplying first term by 10, we get the second term. Again multiplying by 10, we get the next term and so on. The ratio is constant everywhere and it is 10. So let this be required sum S. Now 10, 10 square, 10 cube, so on is a GP with A equal to 10 and R equal to 10. So this bracket is sum of first n terms of this GP. Now sum of first n terms of a GP Sn is given by the formula A r raised to n minus 1 upon r minus 1. We have two formulas. either this, or we can write this as 1 minus r raised to n upon 1 minus r. Now why we are using this? Because r is greater than 1 here. R is 10. So we are using this formula. So let's substitute the values. A is 10. R is also 10. So 10 raised to n minus 1 upon 10 minus 1. So this becomes 10. 10 raised to n minus 1 upon 10 minus 1 is 9. So this is a sum of these terms in the first bracket. So let's write the sum. So required sum S is 5 by 9 as it is. Now sum of these terms. So sum of these terms is 10 raised to n minus 1 upon 9 minus n. So this is the required sum. Okay. So the given sequence is not AP and not a GP, but we are converting this into a GP. So let's solve one more question of this kind. Find the sum of the numbers 0.6, 0.66, 0.666 and so on up to n terms. So the only difference here is we have this decimal point here. In the previous question we have 5 plus 55 so on, but the technique is same. So to add these numbers, take 6 common. Taking 6 common, here we have 0.1 plus 0.11 plus 0.111 and so on up to n terms. Now let's multiply this by 9 and divide by 9. So 6 by 9 multiplying by 9 we have 0.9, 0.99, 0.999 and so on. Now this is 2 by 3. Now 0.9 is 1 minus 0.1. This is 1 minus 0.01. The next one is 1 minus 0.001. So the difference between the previous question and this question is, in the previous one, each bracket has that minus 1. The second term was minus 1. Here it is, first term is 1 minus some term is there. So let's collect this 1 from each bracket. So 1 plus 1 plus 1 so on n times. As we have n terms, we have n brackets and we are collecting this 1 from each bracket. So we have n times 1. Then take minus sign common from the second terms and collect those terms and write in the second bracket. 0.1, 0.01, 0.001 and so on up to n terms. Now here this first sum 1 plus 1 plus 1 n times is n minus, you can see this is 0.1, this one is 0.1 square, this is 0.1 cube, so on. So the nth term will be 0.1 raised to n, as it is 0.1 raised to 1, 2, 3, nth is n raised to n. Now these terms in the second bracket, they form a GP. 0.1, no, 0.1, 0.1 square, 0.1 cube, they form a GP with first term a equals to 0.1 and common ratio is also 0.1. See, 0.1 square upon 0.1 is 0.1. 0.1 cube upon 0.1 square is also 0.1. So common ratio R is 0.1. Now formula for Sn. Now R is less than 1. So let's write the formula. A into 1 minus R raised to n upon 1 minus R. This is 0.1. 1 minus 0.1 raised to n upon 1 minus 0.1. So this is 0.1. 1 minus 0.1 raised to n upon bracket complete 0.9. So we can remove these decimal points. So the required sum S is 2 by 3 n minus, now let's write this sum, and that sum is 1 by 9, multiplying both numbers by 10 into 1 minus 0.1 raised to n. So this is the simplification. Okay. Now let's see what is harmonic progression. Harmonic progression means if we take the reciprocals, those reciprocals, they are in arithmetic progression. So here sequence Tn is known to be as harmonic progression. If taking the reciprocal, we get 1 upon Tn if it is in arithmetic progression. That means the difference is constant. So example given is 1, 1 by 2, 1 by 3, so on. You can see here that the reciprocals are 1 as it is 1 upon 1. So 1, 2, 3, 4, 5. So this is arithmetic progression. So their reciprocals, they form HP. If we take reciprocal of these numbers, we get 3, 18, 13 and so on. See, the difference is constant, so it is AP. So as it is AP, their reciprocal, they form HP. Okay. So let's solve question based on HP. Find nth term. Find nth term and hence 10th term of the sequence 1 by 2, 1 by 5, 1 by 8, 1 by 11, so on. So here we can see that 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So adding 3 we get the next term. That means difference of these numbers, they are same, they are constant. So if we take the reciprocals are 2, 5, 8, 11 and so on. So this forms an AP with A equal to 2 and common difference D is 3. So reciprocal of this AP, it forms an HP. So to find the nth term, we have to find out nth term of this AP and we have to write the reciprocal for nth term of this HP. So nth term of an AP is given by A plus n minus 1 into D. A is 2, n minus 1 into D is 3. So this is 2 plus 3n minus 3. That is 3n minus 1. That means nth term is 1 upon 3n minus 1. We can verify this. Let's put n equal to 3 and let's check whether we get this third term or not. If we put n equal to 3, 3 into 3, 9 minus 1 is 8. So 1 by 8 is the third term. So we can verify that. So this is nth term. This one is nth term of AP and this is nth term of the given sequence. Let's write here that nth term of given sequence. Okay, so 10th term is asked. So T10 is 1 upon 3 into 10 minus 1. So that is 30 minus 1, 29. 1 by 29. So let's solve one more question. 2 by 9, 1 by 7, 2 by 19, 1 by 12, so on. So let's write the reciprocals and let's check whether it is HP or not. Okay. So the reciprocals are 9 by 2, 7, 19 by 2, 12, so on. Let's find the difference. 7 minus 9 by 2. 7 into 2, 14 minus 9. 5 by 2. Now 19 by 2 minus 7. So this term minus this term. So 19 minus 14. That is also 5 by 2. Next is 12 minus 19 by 2. It is 24 minus 19. So 5 by 2. So we can see here that the difference of the consecutive terms here, they are same, 5 by 2. So this is this reciprocal of the given sequence form an AP. A is first term is 9 by 2 and common difference D here it is 5 by 2. So nth term of AP equal to A plus n minus 1 into D, that is 9 by 2, n minus 1 into D is 5 by 2. So that is divided by 2. Both the terms they are having that divided by 2. So let's write only one denominator. Now here numerator is 9. 5 into n minus 1 becomes 5n minus 1 into 5, that is minus 5. So that is 5n plus 4 upon 2. This is nth term of AP. So now nth term of given HP is reciprocal of this. So that is 2 upon 5n plus 4. You can verify putting value of n since these terms are given. If we put say n equal to 4, we should get 1 by 12. Let's check. If n is equal to 4, 5 into 4 is 20. 20 plus 4 is 24. So 2 by 24. So 24 dividing by 2 we get 12. So it is 1 upon 12. So that number is given here. So it is verified. Now as 10th term is asked, put n equal to 10. 5 into 10 plus 4. So that is 2 upon 50 plus 4. 2 by 54. That is 1 by 27. Okay. This is your today's assignment. Find the following sum up to n terms. First question is 3 plus 33 plus 333 and so on. Take 3 common, multiply and divide by 9. Convert this into GP and solve it. Similarly, the second question. The next one is find the nth term and hence ninth term of the HP. First write the reciprocal, verify that it is AP, find nth term of AP and using that write nth term of the HP. Okay. Thank you. See you in the next video.